Okay, let's look at section 7.2, relating the characteristics of an exponential function to its equation. You can find this on page 440 of your textbook. Like all the other videos I made, if you turn to page 448 of your text, you can look at the need to know what we'll talk about. Okay, so on page 448, key ideas. In a table of values for an exponential function, there is a constant ratio between consecutive y and x values increased by the same amount. The value of this ratio is equal to the parameter b of the function. Okay, so b is the one that shows you where your actual ratio is, or relationship with x and y. In an exponential function, the form y is equal to ab of x, a is a non-zero, b is a multiplier. A is a non-zero multiplier, and b is the base, where b is greater than 0 but cannot equal 1. The value of a is the y-intercept of the graph of the function, which you're going to be looking at a lot in this section. Okay, things you need to know. An exponential function is an increasing function if a is greater than 0 and b is greater than 1. So increasing of that. If it's decreasing, if a is greater than 0 and 0 is greater than b, or it's between 0 and 1. So if b is a decimal, that means you're looking at a decreasing function, okay, or a fraction. Okay, so it's got to be between 0 and 1. That's a decreasing one. Anything where b is greater than 1, it's an increasing function. Okay, so it's dependent on b. Changing the parameters a and b in exponential functions of the form y is equal to a of bx. It does not change the number of x-intercepts, the end behavior of the domain, or the range of the functions. These characteristics are identical for each of them. So let's review from last video. How many x-intercepts does an exponential function have? It has none, because it never actually touches the x-axis. Your y-intercept for these graphs is always equal to your b term. Your domain, which is related to x, is equal to element of the reals. And y is, your range, is equal to your y, and your range is always greater than 1. Okay? So let's look at some questions for this example, or this section. Okay, so example 1, which you can find on page 442, says predict the number of x-intercepts and the y-intercept, the end behavior, the domain, the range of the following function. So use the equation of the function to make your predictions. Verify your predictions by creating a table and graphing the function. So for those of you that have never seen the little e value, the e is like pi. So it's an irrational number and it has its own expression that goes on. So if we go to our graphing calculator, we can just hit second function and the divide sign, and you get the little e. If you hit enter, it starts saying the value of e. So e is 2.718281828, blah, 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 on and on, just like pi. If I want to graph the function, I go into my graphing parts, my y equals, I hit second function e. I'll clear it and I'll show you what I did. I hit second function divide to get the little e. Then I hit the little hat above, which is my exponential to raise, and I hit an x. Okay, if I go to graph this function, oh, wait. I noticed that I still have some scatter plot data. So from last section, we used scatter plot. So I have to go second function y. I kept this on so I could show you how to shut it off. If I hit enter on there, I just move over to off to shut the plot off, and then I can go back to my graph. Okay, so my graph of E, if I could go to window and hit 6 to make it standard. I don't know if this thing doesn't freeze. If I go to window, and if I go to, oh, pardon me, zoom, that's what I meant. Zoom 6, I gotta go to my standard. And then I can look at my graph again. Okay, it looks like my graph is right at the x-axis, but no, it actually can't touch it, and it goes up in an increasing form. It's increasing because my b value, which is equal to e, is greater than 1. Okay, so we're going to predict some behavior based on this. So some of the behavior. So it has 0 x-intercepts. Okay. It has 0 x-intercepts. The y-intercept is equal to the e. The end behavior, it always goes from quadrant 2 to quadrant 1 if we look in the graph. And the domain is x of the reals, and the range is always y is greater than 0. Sorry, I always think it's y is greater than 1. So y is greater than 0 for this curve. Okay, so let's look at our next one. We flip through here, flip through example number 2. I look at this exponential function. And I right away know, without even graphing it, that my y-intercept will equal 9, because that's my a value. And my b equals 2/3. Now, is 2/3 between 0 and 1? Yes, it is. So this is a decreasing exponential function. Okay? Exponential, shorten it, function. I also know what? I know that my x is an element of the real, and I know y is greater than 0, and I know that it has 0 or no x-intercepts, right? So I know all this from last section and just from looking at the graph. So if I go to graph this one, if I go to my y, I'll just put it against the other one. I'll just graph it there. So 9, I'm going to put my 2/3 in brackets. So 2 divided by 3 in brackets. And I'm going to raise it to, x. Where's that? And I'm going to raise it to x. And I'm going to graph it, and let's see what happens. Looks like I get a straight line higher up. So I'm going to have to go up to 9. Oh, there it goes, finally decreases. Okay, so that's a decreasing function in red. Okay, it crosses at 9 on the y-intercept, y-axis, and drags all the way down. It says I can actually drag the screen. Okay. So example number 3 in your textbook looks at just if I gave you a bunch of graphs, which equation matches the graphs that I have. Well, if I look at the graphs, the easiest thing to do is sort them into increasing and decreasing function, right? So this one is a is increasing because it goes from 0 up and the y values are increasing. This one goes up, increasing as well because my y values are increasing. Okay, this one is coming down, and so is this one. So these are both decreasing. Okay, so let's look at my equations. So I have 2 that'll increase and 2 that'll decrease. So the ones that are going to decrease have a value of b that's between 0 and 1. So this one and this one both have b as a decimal value. And then y, or pardon me, the other two have a value of b that is greater than 1. So if I look at the first one, or I, it's y equals 3. And then 0.2 in brackets, and then raised to the power of x. What does that 3 tell me? 3 is its y-intercept, so where it crosses the y-axis. So if I look at my 2 decreasing graphs, I try to look for 3. So this one crosses at 3, this one crosses at 4, so this is obviously the I equation where y is equal to 3, 0.2 raised to the power of x. If I look at my other decreasing one, it has to be what's left over. And if I look at y is equal to 4, it corresponds that it crosses the y-axis at 4, 0.5 x squared. Now if I look at the other two, one has a y-intercept of 4, and one has a y-intercept of 2. This one has the y-intercept of 2. So this is going to y equals 2, 4 raised to the power of x. And this one's going to be y equals 4, in brackets 3, raised to the power of x. Okay, so you're just looking at its characteristics, and you're using that to predict the value of it. Okay, so your questions for this one is found on page 448. And you're going to look at questions number 5, 6, 8, and 12. Okay, the next sections we're going to start getting into word problems with these.